Welcome once again to my new calculus channel. My name is John Gabriel, and in this video I'm going to I'm going to talk about a conversation or a discussion that took place on academia, and that's a site on the internet, and I'll provide the link in the details section so that you can actually access it, and just talk a little bit about the different perceptions of time and clock. So this article was written by Bruce Nuppy, who has a Master of Science, and I think he's a psychotherapist and also a doctor, if I'm not mistaken, in the state of Florida. So his views are pretty similar to mine, but he just wanted to put out feelers. So there were approximately 40 participants, but if you read the garbage that everybody posted here, it's quite incredible. So, for example, Jeremy Fiends, he's an electrical engineer, and Attila Colombo, I don't know what he is because he doesn't say. And of course, there are many others here who contributed their 2 cents. John Eric Persson, he happens to be some engineer as well, or a physicist, and simply doesn't have a clue what is time. And if you read the comments that he posted, they're quite outrageous, just like all the other especially this guy here, Manfred UE Pol, and I think he has some kind of job in theoretical physics, if I'm not mistaken. I'm not sure, doesn't say. But anyway, their comments are all garbage, and so I put in one last comment here to explain what is the concept of time. And of course, if you click on my special article, which is called "What is Time?" it explains all these things to you. And so I would encourage you to, I'll also put a link to this and encourage you to study it. So a very brief last comment that I put here. People just don't seem to understand time, especially the scientists and those who call themselves theoretical physicists. The Earth's rotation speed at the equator is approximately 463 meters per second. And so the distance covered in 1 second is naturally approximately 463. And I shall stop saying approximately because that's all it will ever be. So what this means is that 1 second is equal to 463 meters divided by 463 meters. So you see the second is defined in terms of distance, right? So if an object travels at the same speed as the Earth at the equator, then a distance of m meters takes naturally m divided by 463 seconds, doesn't it? And so of course, to measure time with respect to different speeds, 1 second represents 463 meters at a speed of 463 meters per second. Now, if an object travels 100 meters at the same speed as the Earth at the equator, then the time taken will obviously be 100 divided by 463, right? In other words, approximately 0.21 seconds. And so, generally, if an object is traveling at x meters per second for 3 seconds, then how much distance would have been covered at the Earth's equator from an object's fixed location to its new location, right? So that means if you fix a position at the Earth's equator, where will it be when that period has elapsed? And it'll be exactly 463 meters away. So now in this case here, if it's x meters per second and it's 3 seconds, it's simply 3 times 463 meters. And so you'll notice that the speed that the object is traveling has nothing to do, it has no effect on the calculation on this object's position. Okay, so that object will still have moved only this distance. So when we think about a second, we are really thinking about the standard time unit, which tells us that the time duration takes as long as the Earth does to cover 463 meters at its equator. So another way to think of the second is, for all intents and purposes, to think of the distance 463 meters being traversed at the equatorial rotational speed of the Earth. Okay? So water clocks, hourglasses, atomic clocks, etc. are all calibrated to the Earth's second. So if an object travels 650 meters in 1 second, then we know it takes as long as the Earth does to rotate through 463 meters. So these time measuring devices help us understand a given period of time by relating time measure to the standard for each 463 meters covered at the equator. So because we have a good notion of time in any given day, and also the hours, a good notion of the hours, we can easily relate to Earth time. Just imagine if we based our time on a standard from another planet where each rotation takes 2 Earth days or half an Earth day or some fraction of an Earth day. It would be absurd, right? We wouldn't have a good notion of time at all. So therefore time is a very well-defined concept, and it has nothing to do with the nonsense of Einstein, Hawking, or any other theatrical physicist. That is space-time, time dilation, time expansion, curvature of space-time, etc. That's all garbage. And so what I tell you is now to study my article, because all these details are in the article and much, much more. So I'm going to leave you with that. My name is John Gabriel. This is a new calculus channel. Until next time, goodbye.